This will be our lesson on continuity. And for the first part, we need to discuss the definition. A graph is said to be continuous if there are no breaks or holes in the graph. So again, here, to fill in the first part, a graph is said to be continuous if there are no holes or breaks in the graph. If there are breaks or holes in the graph, it is considered to be discontinuous. Okay, and notice we have, if we are discontinuous, we have specific types of discontinuity. And notice the first one would be shaped just like what they have here, and it looks like we have a vertical asymptote through here. And so anytime you have something that is looking like this, then we're going to have what is called an infinite discontinuity. Okay, over on this other part, if you'll notice how we have our graph, it looks like you're going to have to jump to get to one part of the graph to the other. And so this is really called just a jump discontinuity, because you can jump from one part to the other. And then notice this other part, and we'll get into later why it's really called removable. But here, this is called a removable discontinuity. And you do need to be familiar with those and able to identify them graphically. So in our examples, looking at this, we need to describe what kind of discontinuity we have and where does that discontinuity occur. So for this first one, this should be a jump discontinuity, and it's going to occur at x equals -5. It's happening right through there. Okay, this other one, well, this function, notice it doesn't look like any of the others. We don't have any breaks or holes. So this function here is just going to be a good old continuous function. Number 3 definitely is not continuous. And notice right through here, it almost looks like we have an asymptote there. So this is going to be an infinite discontinuity. And it's an infinite discontinuity at, it looks like, x equals 1. Right? And looking at number 4 appears to be continuous. There's no holes or breaks in it. Number 5, we have a hole in the graph, and so that's going to be a removable discontinuity. And it's going to be at x equals -3. And finally, oh wow, 6 looks like it's got a couple of discontinuities here. One, we have an infinite discontinuity. And that infinite discontinuity is going to be at x equals 2. And then we have a removable discontinuity. And that's going to be at x equals, let's see, at x equals 1, 2, 3, maybe at x equals 4. All right, moving on. Right, now along with in behavior, we are going to talk, or with continuity, we're going to talk about in behavior. And you all explored the in behavior a little bit last year, but we do need to make sure we understand what's happening. So on this first part here, as x tends toward positive infinity, so as our domain for x continues on to grow, what is my function tending toward? Well, notice the function is moving downward. So notice we're heading toward negative infinity as x grows without bound. So here, this one would be negative infinity. Now let's let x approach negative infinity and see what happens here. So as x is tending toward negative infinity, my graph is moving upward, so that side is tending toward positive infinity. Alright, so let's look at our examples, talk about our end behaviors, and we're just interested in x approaching positive or negative infinity. So for number 7, as x approaches negative infinity, what is f of x approaching? Well, f of x is approaching, notice as x tends this direction, notice that y is increasing without bound, so it is tending toward positive infinity. And on the other side, as x approaches positive infinity, what is f of x approaching? Well, f of x, again, if we're tending toward positive infinity, notice that my function is moving upward, so it's tending toward positive infinity. On number 8, again, we need to start out with x is going to approach negative infinity, and notice what's happening to our function this time. Our function is approaching negative infinity, because again, as x is tending to the left, my function is tending downward. Okay, let's investigate over on the other side. As x is approaching positive infinity, notice that f of x is approaching negative infinity. So it's okay that f of x on both sides were approaching positive infinity and negative infinity. That's not going to matter. You're not always going to know or have different ones. Alright, so now let's look as x approaches, again, negative infinity. Our function itself, notice here, as my function is tending toward negative infinity, my function is tending downward, so f of x is approaching negative infinity. As x approaches positive infinity, it looks like my function itself is approaching. It's not equal to, it is approaching, and it could very well be equal to, just nothing says it has to at the moment. That's going to tend toward positive infinity. The next thing that we have is we're going to look at when graphs approach a certain value. So it doesn't have to be positive or negative infinity. We might have a horizontal asymptote, and that's going to be what our values are going to be approaching. So as x approaches positive infinity, notice that my graph is flattening out, and it's really staying constant after a certain value. And so that's going to be, for this one, we are approaching -1 from our function's point of view. And the same is going to be true for the other one. As x is growing without bound negatively, then we are flattening out and tending toward -1. Alright, so let's talk about some of these here. So by that same idea, we do need to talk about the end behavior. So we're going to talk about as x tends toward negative infinity, what does it look like my function is tending toward? And notice here, as we tend toward negative infinity, we are going to run parallel to that x-axis. So that means f of x is going to tend toward 0. So let's go the other direction. As x approaches positive infinity, what is f of x approaching now? So again, and even as we do cross here, it's almost like the function comes back and it starts leveling out. So again, on that side, we are approaching 0 as well. Alright, let's look at our next example. And again, x is pretty much well constant and approaching positive and negative infinity. But what is f of x going to be approaching? So again, as x is approaching negative infinity, let's look at what it looks like this graph is doing. is it's starting to tend outward, and it looks like it's flattening out at maybe 1, 2, maybe 3. Here, notice the arrow is still going upward a little bit. So here we're tending toward -3. And x approaching positive infinity, looks like f of x is approaching the same value. It looks like there's a horizontal asymptote there, and our graph is leveling out, and so again -3. Okay, number 12. So x is approaching negative infinity. So what is our f of x approaching? So again, as x is approaching negative infinity, it looks like our graph is flattening out maybe and tending toward +2. And then let's investigate over on the other side. It looks like f of x is approaching here. Looks like it's approaching that same value on each side. So it looks like it should be approaching 2 as well. Right? And number 13 looks strange, but again, don't let all the stuff in the middle mess you up, because we're not really talking about as x approaches the middle. We're talking about x approaching negative infinity. So what is our function approaching? And I keep writing equal, sorry folks. So as x is approaching negative infinity, what does it look like our function is flattening out and doing? Well, it looks like, let's see, 1, maybe -2 is what that function is flattening out to be. And again, as x approaches positive infinity, f of x, it looks like it is approaching -2 on that side as well. So don't let this gobbledygook here in the middle mess you up. You don't even pay attention to that, because we're really more interested in what's going on as x increases without bound and decreases without bound. Right? And then number 14. So knowing that the middle stuff's really not going to be of our major concern here, hopefully that helps us see for 14 that our function is tending toward 0. And as x approaches positive infinity, again, even on that side, it looks like our function is approaching 0. And then 15, same idea. X is approaching infinity. So what is f of x approaching? Negative infinity has been what I've been putting. So as we are approaching negative infinity, what does it look like this function is approaching? Well, it looks like it's starting to flatten out. Let's see, there's 1, 2, 3. So it looks like we might be flattening out toward, oh, nope, not going to be on that side, is it? That's tending upward. We're looking at, gosh, let's see. Yeah, we're going to be tending toward positive infinity. I was thinking we were looking at the right, sorry. This one is tending toward positive infinity, gracious. So now let's look at as x approaches positive infinity. Now what is f of x approaching? Here we go. So now we're flattening out, and that looks like we're at 1, 2, 3, 4, maybe at -5. We're flattening out there.